Hello everyone and welcome back to this next lecture. So this is where we had left off in the previous lecture where we had compiled the driverlib project. So we have now compiled both our projects, that is bitfield and driverlib, and we are now ready to execute them. So at this point I'm going to bring the microcontroller into the video. So you will now see the microcontroller into the video, and here in this case I have now more connections brought out, and that is simply because for each CPU we are now controlling two EPWM modules, and within each EPWM modules we are extracting both the outputs. So therefore there are 4 wires connected for each CPU. So this is all CPU1 and this is all CPU2. So with this we can now zoom in to the oscilloscope and we can get started with moving into the debug mode with respect to bitfield project. So in this bitfield project, I'm going to go into the debug mode. So it is in the halted state. But again, before I execute this project, let me go and copy over those variables which we would like to put in the watch window. So in this case, we want to add dir CPU1, and let me add this to the watch window, and let me add mode CPU1 as well. And both of these are in the continuous refresh mode, so we know we are always going to see the latest values even if they change elsewhere. So with this we can now start with our execution, and in the beginning this is in the forward boost mode because the direction variable is positive and the mode variable is also positive. So if we execute it, you will see that now the yellow waveform is the A output of EPWM1 and the blue waveform is the B output of EPWM1. So which means that the device S1 is completely turned on and the device S2 is completely turned off. Now let's come over here and I'm going to change the connections to S3 and S4. So now the yellow waveform is connected to S3, which is the A output of EPWM2, and the blue waveform is connected to S4, which is the B output of EPWM2. And you will see that now S4 is operating and S1 is completely turned on and the other two are off. So I'll just bring it over to S1 just to indicate that these are the ones which are actually not turned off. So now the yellow waveform is S1, which is the A output of EPWM1, and the blue waveform is S4, which is the B output of EPWM2. And here you can compare, you can also go back and check with the code that this is indeed the logic we want. And you can also compare this with the simulation, and you'll see that this is exactly what has been done in the QSpice simulation as well. So now that this is done, let's change the mode, and I'm going to change the mode to the buck mode. So I'm going to change this value to -1 and you will see that something different happens. So now you will see that the yellow waveform is S1. So I'm going to bring this over. So now the yellow waveform is S1, which is the A output of EPWM1, and the blue waveform is S2, which is the B output of EPWM2. So in this case S1 is operating. So now I'm going to change over these connections to EPWM2. So now the yellow waveform is S3, which is the A output of EPWM2, and the blue waveform is S4, which is the B output of EPWM2. And you will see that these two devices are completely turned off. So in the forward buck mode, only the device S1 operates. So I'm just going to bring that back again to give you an idea. This is now S1. So S1 alone is operating in the forward buck mode, and this is indeed correct. So now let's change over our mode to the reverse power flow mode. So I'm going to change this value to -1. And the minute I change this value to -1, the gate pulses disappear from S1. And now let me go over and put this on S2. So now the yellow waveform is S1, which is the A output of EPWM1, and the blue waveform is S2, which is the B output of EPWM1. So in this case, S1 is off and S2 is on. So now let's check out the other two. So here in this case, the yellow waveform is S3, which is the A output of EPWM2, and the blue waveform is S4, which is the B output of EPWM2. So this shows that S2 is operating and S3 is completely turned on. So here I'm going to bring this back. So now you will see that the yellow waveform is S2 and the blue waveform is S3. So this implies that S3 is completely turned on and S2 is operating. So this is the reverse buck mode of operation. So you can compare this and check whether this is indeed correct. I will leave this to you as an exercise. And the last mode is the reverse boost mode. So I'm just going to change this mode to 1. And now let's go back and check everything again. So I'm going to move the yellow waveform back to S1. So now you will see that the yellow waveform is S1, which is the A output of EPWM1, and the blue waveform is S2, which is the B output of EPWM1, and both are turned off, which means neither S1 nor S2 are operating or turned on. They are completely off. So now I'll make over the connections to S2, S3 and S4. So now you will see the yellow waveform is connected to S3, which is the A output of EPWM2, and the yellow blue waveform is S4, which is the B output of EPWM2. And now you will see that the yellow waveform is high, which means S3 is operating and all others are turned off. So this is the reverse buck mode of operation. So I would recommend, this is the reverse boost mode of operation. So this is something that I would ask you to run this experiment on your own and verify all these switchings yourself. So now that this is done, let me remove these variables and let's now go and execute the CPU2 code. So first I'm going to connect the target, and once the target is connected, I'm going to load the code. Go over to the correct directory, which is CPU2, which is driver lib, and then CPU2 RAM, and load the .out file. So it is now running and executing. Yes, it is. So now I will go over and copy those variables just like I did in the previous case. So first I'm going to copy over dir CPU2 and I will add this expression, and I will copy mode CPU2 and add that as well. Right? So again, in the initial mode, this is in the forward boost mode of operation. So first thing I'm going to do is I'm going to make my change over my connections to EPWM4 and 5. So now at this point of time, you will see that the yellow waveform is connected to EPWM4A output, which is again S1, but for the EPWM, that is the CPU2. So now all connections are with respect to CPU2, and you will see now that S1 is on, S2 is off, and I'll make the connections now to the other one. And again, the yellow waveform is S3 and the blue waveform is S4. So if I look here, in this case, S1 is turned on completely and S4 is operating. And this is in the forward boost mode of operation. So again, let me just change this to the buck mode of operation. So in the buck mode of operation, now S1 is operating, and let me just move this to S2. S2 is completely turned off, and now this is S3 and S4, both are turned off, right? And this is exactly what we were also expecting, which we saw in the bitfield approach. We saw that only S1 operates, all others are turned off. So now for the last, I will just change this to the reverse mode. And in the reverse mode, let's look at what's happening. So this is the connection of S1 and S2, and you will see S1 is completely turned off and S2 is operating. So let me just check S3 and S4. So S3 is turned on completely and S4 is turned off completely. So this means that in this particular case, S2 is operating and S3 is completely turned on, right? And this is exactly what we also saw with the bit field approach. So there is one last mode of operation, one last mode of operation rather, and that is going to be the reverse boost mode of operation. And in this reverse boost mode of operation, I'm just going to make all the connections back again. So this is S1 and S2, both are turned off. And now I'm going to connect it to S3 and S4. And now you can see that S3 is operating and S4 is turned off. So in this reverse boost mode of operation, S3 alone operates, everything else is turned off. So this is a confirmation that we have got our code working on both CPUs of the F2A37ND, and this I would encourage you to compare these results with the results from the QSPICE simulation. So this is something that I will leave to you as an exercise. So with this, I'm going to end the microcontroller video, and we are also at the end of this particular lecture. So we have one more simulation and one more project to do with respect to the half bridge module, and that is the use of the half bridge module in a DC to AC converter. And this is something that I'll start in the next lecture. So if any of this did not work or you faced any other issues, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening and see you soon. Goodbye for now.